All right, today we're going to go ahead and continue with our graphing of the trig functions. And today we're going to graph the secant graph and the cosecant graph. In order to do that, you really need to know that cosine and sine graphs. Because remember, the secant of x is equal to 1 over the cosecant of x. And I'm sorry, the cosine of x. The cosecant is 1 over the sine of x. So it's beneficial for you to graph the cosine or the sine in order to graph its secant or cosecant graph. We start by graphing its inverse. So for the secant of x, I'm going to go ahead and draw the cosine of x graph, which we talked about last time. So we're going to say this is 1 and this is -1 here. And so our cosine graph starts at 0, 1. It has a period of 2 pi, so it's going to be back at 1 at 2 pi. At the very center of that, which would be 1 pi, it is going to be at -1. And then in between those 2 points, it'd be in the middle. And then that cycle continues. So we lightly draw that graph. Mine is probably a little too dark here, but we lightly graph that first. And that is going to help us graph our secant graph. For the secant graph, once you draw the cosine graph, then we're going to go ahead and draw our asymptotes. And that falls where it is at 0. Because this is 1 over cosine of x, wherever cosine would be 0 is going to make this undefined. So we would end up with an asymptote. So we're going to have an asymptote right here. We're going to have an asymptote at -pi/2. We're going to have an asymptote at pi/2. Anywhere it's back in the middle there, we're going to end up with an asymptote. Once we have drawn the asymptotes, and remember, asymptotes guide your behavior. So once we've drawn our asymptotes here, then we are going to go from the asymptote to the point there and back towards the asymptote. That is our secant graph. Now, to make it clear, this cosine graph is not part of the graph. It's just, it makes it easier to graph by drawing that first. And then its vertex there to the asymptotes is the actual secant graph. Its period is the same as the cosine, 2 pi. So we'll go ahead and put that here. The period is equal to 2 pi because from this 0 to this 2 pi, we have a full cycle. So we've got this side, and then the bottom would be considered one cycle. So let me just mark that off so you can see that is one full cycle of the secant graph right there. We are going to end up with an asymptote every pi. So we start with this one, and every single pi, we're going to have an asymptote. So we can say we've got a vertical asymptote at x equals pi/2 plus n pi. For our cosecant graph, we said that's 1 over sine, so it's beneficial to graph our sine graph. So we start with that, and our sine graph started at 0, 0. It had a period of 2 pi, so it would be back at 0 there. Dead in the center, it's going to be at 0, and it goes up 1 and then down 1. These are fun to graph. We lightly draw these in. Just like with the secant graph, anywhere our sine is 0 is going to make this undefined, so it creates that vertical asymptote. So we're going to have a vertical asymptote here. We'll have another one There'll be one right on the y-axis, one at pi, and one at 2 pi. And then just like the other one, we'd start at the vertex there and head on towards our asymptotes. Just like the parent function, I'm sorry, just like its inverse function, the sine function, it too has a period of 2 pi. This one again starts from 0 to 2 pi right there. So there's a full cycle, one on the top and one on the bottom. So there is our parent function for the secant and our parent function for the cosecant. Of course, when we introduce our parent functions, we use transformations afterwards so that we can graph any of them. So let's look at those. So here's the instructions on graphing those. First, you start by graphing the sine or cosine. You do all the shifting you need to do. Then we do not connect the points. We draw the asymptotes through the middle points, and we sketch the reflections of the graph from the high and low points. So let's look at some of those. All right, we're going to start pretty easy on this one here. It tells us y equals 3 secant of 2x. So first, let's start by answering the questions here. A would be 3, our B value would be 2, our C value, there is none, and our D value, there is none of that one either. Remember, A is the one in the front, B would be right up front here, which is the 2. C is when we're adding or subtracting on the inside here, and D is when we're adding or subtracting at the end. For amplitude on secant and cosecant, they have no amplitude. As it goes up and down in both directions forever, it can't really have an amplitude. For the period, the standard period is 2 pi. So just like with the cosine and sine, we take that 2 pi and we divide it by the B value. So I'm going to go ahead and take 2 pi and divide it by 2 here, and we get pi. So this one's going to have a period of pi. That means a full cycle is going to occur within that pi. For our shifts, we've got none. Since this had no C or D, we're going to go ahead and sketch the graph down here. So we said with the secant, I start by graphing the cosine graph, and I'm going to sketch it with these parts right here. So for our cosine graph, and I'm going to lightly make my lines here, it would have an amplitude of 3. So that would be my high point, and this here is my low point. Remember, the cosecant and the secant do not have an amplitude, but since I'm sketching my cosine to go with this, that's where we're going to get that from. So the cosine starts at the top, so my first point is going to be up here. It has a period of 2 pi, but we've just discovered that the period here is going to be pi since the B value is 2. So this would be back over here. In the center of those two, we would be at the bottom. And then in between those, it would be on 0. We care about those points, so we want to make sure we graph them on this one, since that's where our asymptotes are going to be. And so we do the same thing again. So from 0 to pi, there was a point here. And so at 2 pi is going to be another cycle. So that's going to be back at the top. Right in the middle, we've got our point at the bottom. And then our middle points would be right in between those. That pattern continues to the other side here. Again, these middle points are important because that's what's going to make our asymptotes. So I don't even have to connect these points, or I don't have to draw the entire cosine graph here, because what I need is the asymptotes that come from that middle point. So I'm going to go ahead and sketch it. On a quiz or a test, really, if you showed 3 cycles on this, it would be okay. So something like this that has a lot of them, you wouldn't have to draw the whole thing. I'm going to go ahead and draw the whole thing so you can see all of it. So I am making an asymptote at each one of these 0 values. All right, so now we've got all of our vertical asymptotes. Once the vertical asymptotes are graphed, then you can use those vertical asymptotes in that top point to make the top values, and then you can make the bottom ones there. On these, as we grade them, what we're looking for is that your asymptotes are in the correct locations, and then that it moves towards the asymptote. And so we have a graph that looks like this. And these are pretty cool to graph. All right, we are going to look at some that are a little bit harder, but before we do that, we'll go ahead and look at one of the cosecant ones with some transformations. So let's go back to that first page that we were working with here. All right, so we're going to try this one here, 2 cosecant of x plus pi over 4. So this right here tells me to go to the left pi over 4. And this right here tells me that the sine curve is going to have an amplitude of 2. Remember, cosecant and secant do not have an amplitude. That's that vertical stretch. All right, this does not have a b value, so our period would still be 2 pi. That hasn't changed since there was no b value. So we're going to start by drawing our sine graph here. It's still going to have a period of 2 pi. So those are the initial points right there. Now we do have to take into account this left pi over 4. So I am going to move to the left pi over 4 for this first one. And then I'm going to do the same thing for this one. And so there is my new period. I've got one full period is going to occur between these 2 points. We know that we're going to have to split this up now. So in the middle here, it was supposed to be back at 0. That 2 would move pi over 4. Everything moves to the left pi over 4. At pi over 2, we would be up here at positive 1. But again, we need to move that to the left pi over 4. And then right here, we would be at negative 1. We're going to move that. So that would be our period for our sine curve moved to the left pi over 4. And then we went up to this 2 and negative 2. We continue that same pattern. So I'm going to go ahead and draw the rest of my points for the pattern before we do our asymptotes. All right, once we repeated that pattern on our points, then we want to look at the ones that are on the x-axis right here. That middle value is the one that makes the asymptotes. So on our middle value, I've drawn my asymptotes. And then I go ahead and sketch my graph by using the asymptotes and that top point, or the asymptote and the bottom point. So the period on these are still 2 pi. So within a 2 pi period, you still have the entire thing. So all of this is 2 pi. And all of that is 2 pi. So you still have one cycle within 2 pi, but it's all shifted to the left pi over 4. And that 2 did that vertical stretch in the middle here. So there's a gap of 2. We'll go ahead and do one more. Here's another secant graph. And this one has a vertical shift here. So it's going to go up 1. This is going to go to the right pi over 2. And then it's got that vertical stretch of 2. With the secant, the cosine curve is the one I'm going to want to graph first. And this one did move up 1 unit. So our center line is now going to be at 1 instead of 0. So I'm going to go ahead and graph that, just a line there to keep me focused on where it's at. The amplitude for the cosine curve is going to be 2. So I'm going to go 2 above that new center line and draw that one. And then below, I am going to have a lot of lines on this one, so I want to be careful to make them light so I see what I'm doing. With the cosine curve, it starts at the top here. So this would be my first point. It has shifted to the right pi over 2, so that's going to move over here. The period is still 2 pi since there's no b value change there. So 2 pi after this, I would be back at the same spot, so that's going to be right there. In the middle of those two, I'm going to have my point at the bottom. And then the pattern repeats. So I would do the same things on the side. Before I continue to graph those, do remember that in the middle here is important because that's where our asymptotes are going to be. So we didn't talk about that. So this is 1, 2, 3, 4, 5, and 6 units between this one and this one. So at 3 units, it would be back in that center spot. And then 1, 2, 3 back in the center spot to create that full first cycle. Everything has moved to the right pi over 2 because of this. So we went, that point that was at 0, 1 moves to the right pi over 2. The next point that would have been at pi over 2, 0 has moved to the right pi over 2. So that's the one that put it here. And then of course the up 1. And so everything has moved to the right 0.1. And then that's where we repeat the pattern. So it would be back up on top here. And then we keep going on the 3 values in between. So 3 values here, down, back in the middle, back in the middle, and then down. And the ones that we care about are the ones that would have been on the x-axis. The center ones are going to give us our vertical asymptote. So I've got a vertical asymptote there. I've got a lot going on my graph here, so you want to be very careful with these. I know it looks crazy with all of the dotted lines, but keep in mind, these are my vertical asymptotes. The other ones I kept there just to give me an idea of where my cosine is. If you want to go ahead and lightly graph that just because it helps you see it, then go ahead and do that. But you do not have to connect those points if you don't want to. The part of the graph that matters is the one that's in between those asymptotes and goes from the top to the bottom. Again, these are really fun graphs to do. You just want to make sure that you practice. That way you're getting all of the parts of the graph together. Next class, we'll do the tangent and cotangent.